Thank you. Thank you. Good afternoon. Thank you so much for staying for the whole conference and getting your money's worth. As Ashley said, I'm Jonathan Owens. I've been doing site reliability work for about 10 years now, 4 of them at New Relic.
I'm Jose Fernandez. I've been at New Relic for a long while, I think over 5 years now, and I love the JVM.
That's a rare quality. So we're going to present some service architecture patterns that our team at New Relic uses to destroy monoliths one piece at a time. If you agree to these terms and conditions of the talk, say aye. Wonderful. Jose and I have had the wonderful privilege of being here with our families, though as you can imagine, traveling with kids under 6 on a plane and staying in a hotel is pretty hairy. Things might get a little punchy. Bear with us. Who works with software like this? Big, square, no, not square. Sheer, you can't do anything with it. You don't know how it works inside. You can't like put anything on it and nothing sticks to it. It's just miserable. You don't know why it's breaking. You don't know why it works. Does anyone even know how this thing got here? It's so heavy. So my team has one of these, and we're in the process of breaking it up. Now, if you're lucky enough to have one of these, it's probably actually a good problem to have. It means your company has been successful enough to actually build a piece of software to be big. You know, you either die a microservice or live long enough to see yourself become the monolith, right? And our monolith grew right along with the company, which is to say really fast. We've seen super linear traffic growth for 8 years straight, and the code base has grown at what feels like the same rate. So the business itself is a success. Working on the software maybe isn't, and everybody that touches the thing gets sad. This is kind of not a good situation. This is a very money-centric point of view about software. This is my son on his first airplane ride 2 days ago. The feeling in his heart right here, the thrill of seeing something new and endless and fresh, we so rarely get this as adults. But sometimes when we're building software, I feel it. Something new, something that is in the world now that wasn't there before, and something that is uniquely me is expressed in it. Monoliths destroy this feeling. They put you in a box where nothing is possible. We are better than this. But how do we get there? How do we escape this trap? Well, let's make a list. You need a few things. Well, here's one pattern that's worked for us, and here's the things that we did to do it. We'll assume you have New Relic because you're here. And we believe these tools and this pattern can be used by any of you working on any kind of software. We'll start with the specifics of our story, and maybe that'll help sound familiar to you. Storing and collecting the data that customers send us about their software is one of the hardest jobs that we have. It's so hard that we didn't really make something big at first. It was small, but it kept getting harder and harder and harder. We had this giant JVM to do it, and so as the company grew, like you saw in that chart before, this process just grew and grew till the code base started to look like this. And everybody who touched it caught the sad. And everybody knew we had to break it up because we couldn't add things to it anymore. It was too much. But we couldn't break it up all at once because as satisfying as it is to work on something and make it better, that doesn't actually help anybody except for you. And the company's a lot bigger than you and the people working on this problem. So what we learned was that we had to make this thing smaller just one chunk at a time, and then do that again and again and again until it's rubble and the whole new system is running and our world is better. So let's start with what our code base actually does. Oh, crap. OK. It does a lot of stuff. This is why working on it is so tricky, even for our most experienced programmers. In fact, nobody at the company even really understands all of its behavior. You say collector, and people kind of shake. It's a 4-letter word. So, OK, it does all this stuff. How do we pick the right things to extract? We have to be careful. If you pick the wrong thing, you're going to introduce too much risk, and the whole monolith comes down in a bad way. If you pick the wrong thing, you're going to break off too much risk, and it'll take you forever to build it. If you pick the wrong thing, you get the idea. So let's start with the fact that more services isn't the goal. Actually, making people happier is. Making our customers happier is. Making our customers pay us more money so they can get their data faster is. So let's look at the thing that causes the most pain here along one dimension or another. So if we start with developer pane, we're probably not going to do ourselves well because that's going to be hard to extract. So we found the right angle to be scale pane. So the biggest scale thing in here was time series data. Or in New Relic parlance, this is time slices. A single time slice to a relic is one of those red dots on the screen. That is 1 minute of data along one metric from one host. We have a lot of these, hundreds of millions a minute. And so the collector, our monolith that processes this data, is extremely busy working on these things all the time. It has to store both, it has to both aggregate this data, so take all the processes that send this data in 1 minute and glue it all together into a single minute worth of data. And then it has to write it all to MySQL. This is a very big job that is probably suited to more than just one JVM per account doing it. The other nice thing about time slices is they're quite isolated. There's really only one system that writes this data, our monolithic collector. There's one system that stores the data, a whole lot of MySQL. And there's one system that queries the data, this thing called MTS, that just is the guts behind the chart you see here. So while we're pulling this out, let's pull out the storage system too. This might be a little more than we should have bit off, but we decided, MySQL is kind of causing us a lot of pain. It's kind of a junior monolith. So let's use Cassandra, because it's actually scaling to be big enough. And the nice thing about doing that is it lets us build the system on the side. So Jose is going to talk about how we're going to build that system in the dark.
Okay, so the first thing that our managers told us when we were building this, when we were sitting down with the original team, was like, it has to have no customer-facing impact, so zero customer-facing impact. But then how do you access this data that's coming into the monolith so you can work on it, right? Like it's in the JVM. How do we grab it and pull it out? And then, in the company, we've had some experience using Kafka. So somebody in the team had this bright idea, hey, why don't we extract the data and put it into Kafka? There you go. So this is the basic streaming architecture with Kafka. On the left, you have event sources, which Kafka calls producers. So in our world, these are your apps running New Relic. So they're sending us all these information about your app, the metrics, time slice data. And then in the middle, you have these services. It could be like monoliths like the collector or smaller microservices, but in Kafka terms, they are consumers. So these consumers are consuming the data that the producers are producing. And these consumers can also produce more data. And you got this chain of happiness until it gets over to the data store. So at the edge on the far right, you have the consumers that actually write the data out to the data store. So once I went back, so we needed to have access to this data that was coming into the monolith. And we're like, okay, let's put it into Kafka. So this is actually a really, really easy change. If you work on the JVM, the Kafka client is actually really easy and a lot of fun. So we have the data, and now we're emitting a copy of that time slice data into Kafka. And the cool thing is that once we got this in Kafka, we didn't have to touch the monolith. There were some minor changes, but it was like, we're done, and now we can start working on that data stream. So in the end, what you see here, it's not very complicated. So you got the monolith, the collector on the left. It's producing all these events, or the time slice as events. And it's basically making its way towards the far right, which is the data store, Cassandra. And along the way, we could maybe modify the data, append the data, filter out the data, aggregate it. You can do whatever you want to it. But the key part of this is that, so the brown bits that I've highlighted there, those are the Kafka queues. So that's where your data is sitting between consumers, right? And if you think about it, if this was in the monolith, this would be in the memory, right? So if it's in memory and you have to restart it, what happens to that data? It's gone. So we're like, sweet, that's a really useful idea. Now we can iterate on this and not affect the monolith. We're like, hey, what if we can actually do that on the read side, right? So if you think about it, like the data that we're storing, the monolith is storing to the legacy database, which is MySQL. And then the new pipeline that we built is storing to the new database, which is Cassandra, right? So the data that's in both databases has to be about the same, right? If you query it, it has to come the same results. So on the left here, you have New Relic APM. So when you pull up a chart, a New Relic chart, it's actually fetching that data, the time slice data that Jonathan mentioned, from this query service that internally we call MTS. And then the query service, I go into MySQL, give me all the time slices for this chart, and brings it back to APM and displays it to you. So what we did is like, okay, well, cool. Let's add a few lines of code to the query service so that when a query comes in, we're going to also record the results and the performance information about the results. So how long it took to query the database. And then we're going to put that into another Kafka queue, right? And you can see that down there. And then we had this service that's consuming from this Kafka queue and executing the same query to Cassandra, and also recording the results and the query time. So now we have the query information with the legacy system and the new system, how it performed and what it returned, right? So it would have to be the same. So we grab that information and send it over to our Insights product as events. And the cool thing about that over there, that's Insights. So if you haven't used Insights, you should, after this, just go up, start an account, and start sending events. So the cool thing is that here we can chart how well the legacy system is performing against the new system, right? And we saw right away that Cassandra was like just kicking ass. It was way faster, and then the queries were the same. So we knew that we didn't have a problem in a new pipeline where we're inserting the wrong data or maybe like doing something to it wrong. But the cool thing about Insights is that we could also show this data to the executives and the senior managers that are kind of like saying like, are we going to do this project or not? Are we going to rewrite the monolith? And it was just like an easy way to show this. Hey, here you go. You can look at this horse race, and you can see that the results are pretty evident. So that was really cool. That was really cool.
So now that we had this dark environment we could iterate in, we had the freedom to experiment with new limits of performance and new ways we could architect for processing on this data. So let's make things smaller and see what happens. So the Hive machine's running full speed on microservices. Guilty as charged. So rarely does it work out. We do have a success story here, though. There was, for us, some bound north of Hello World where too small was actually a reality. But smaller did actually work out. When we started emitting those time slices from the collector, like cloned sheep, we had one service, this minute aggregator component, that consumed it, aggregated the data, and then wrote out the finished data to Cassandra. We figured simply doing this outboard of the collector would probably be enough. But it really wasn't. It didn't perform nearly as well as we expected, and it put a lot of memory pressure on that JVM. And while it was a nice, simple extraction of the logic from the existing monolith, it wasn't quite up to the task. So since we were working in the dark, since we had this environment that we could prove was faster and correct, we could iterate freely and say, well, what if we split up writing and aggregation? Turned out our service really had two jobs. Those aggregation components and those writing components were radically separate. And because we had that Kafka component that we could just stuff data into freely, it was not too big a deal to split them up. By splitting them, we could optimize those tasks separately. Aggregation is really memory and CPU intensive, and writing was I/O and network intensive, while it sends data out to a remote system. Those are really different performance profiles. And we could learn all this safely without affecting customers because, again, this whole system was behind the curtain. Another interesting thing about this architecture was that the more finally we split those stages up, the more data ended up in Kafka. And this actually yields really interesting opportunities to experiment with that data that we didn't have before. So the thing that comes after the minute aggregator there, that queue, turns out to be really valuable. That's the New Relic data fire hose, the one we've had all along hiding inside the collector that everyone wanted to have access to. We can actually grow on this architecture much more freely than we could before. Here's an idea for another thing we can extract, something called summary records. These are what power the traffic lights and some forms of alerting in our system. This is another job the collector does in its monolithic space, and there's not really a need for it to be in there if we have all the data needed to evaluate that in another queue, or in Kafka parlance, a topic. You can actually create a new outboard system following the same pattern, take the same specification, re-implement it in a new scalable service off that same data pipeline, and then just go delete the code out of the monolith, and you're done. It's really powerful. Nothing in this pipeline needs awareness of this new component. You don't have to get inside the aggregators or the writers to extract this data and do something with it. Nothing in the collector has to change. It can just stay there doing what it does until we delete the code and swap out for the new service. And again, the fact that we didn't have Kafka before, that this data wasn't on the outside, is what led to us having such a monolith. If you put all the valuable data of your system inside one process and one service, things just going to metastasize. You have to expose it. You have to yield it in a way that's going to be useful to other services so they can grow organically. The more you do this, the more you get a feel for it. It starts to feel like these things are separate and yet compose one product, right? So each of these can be great at their own thing, and then together they form like a nice meal into something that actually hangs together, is coherent. And each service can become way simpler. It's easier to optimize, it's easier to monitor, it's easier to deploy, the effects of an outage are narrower. It's just much nicer in general. But how do you find the boundaries? Because one of the problems in many monoliths is that they can be very interconnected. All these different components depend on each other to operate. It's going to be hard to know exactly how to pull them out. We found two rules that are easy to say and kind of hard to follow. The first one is simply Conway's Law. The boundaries of the service should match the communication boundaries of your company. There is a session happening right now opposing this one that don't go to it, go watch the recording, that talks about how we made this happen at New Relic by actually structuring the company in such a way that the services all have a single team owner, and that team represents that service's interface to every other team. And so in our case, since we owned the monolith completely, we can say, we're taking out this part. No one else, is going to be touching that unless we're standing in the way. And we're going to decide exactly which parts get pulled out and who's going to have them. So we had one team steering that whole thing. We still do. That's been really helpful because prior to this organizational change, our monolith was owned and modified by a whole bunch of different people, and they all had commit, and pretty soon it was, as we saw, a ball of snakes. That's not very fun. At least have one person that owns the ball of snakes so they can say, you get a snake and you get a snake, and look under your seat and everybody gets a snake, and someone can know where all the snakes are. Excuse me. The other one we found, so once you've got all that established between teams, individual teams may want to break up smaller services within themselves. So in our case, this was the minute aggregator became 2 services. That had to be experimentally proven. Half the team at the time that was proposed rolled their eyes and said, why in the world would that make any difference? You're doing the same amount of work. And the other half of the team that thought it was a good idea said, well, I'm going to do it, I'm going to prove it to you. And they went and did it, and it was pretty easy because it was a small service. And we saw the charts and went, oh my gosh, that was such a good idea, I don't know why I doubted you. Data's really powerful here. Sometimes it doesn't work out though. Sometimes you break that service up and you go, well, that didn't really do anything. Now I got another thing to monitor, forget it, put it back in. It's got to prove its mettle. But it's not always performance. Sometimes it can be, this is way easier to work on, or this breaks it up in such a way that when our team grows, we can actually hand this service off to another team. There can be just simple ergonomics matters here. Again, having a lot of services isn't the goal or the point of microservices. That's not why we're even breaking up this monolith. The goal is to make this thing scale in a humane way so that you can continue to enjoy working on the software. Just don't make it look like this, We want to avoid these monoliths just like we want to avoid having concerns mixed, just like we want to avoid eating all our food in a big bowl all blended together. Pizza's good and so is chili, but don't make yourself a pizza, crepe, taco, pancake, chili bag. Separate concerns when it's obvious. And the thing that makes this possible in an easy way is having Kafka or some other service bus there. If all your services have to communicate over custom designed APIs with different payloads and different agreements, and you've got cross-team API version disagreements, it can start to get pretty hairy. But if you're stream processing between these services, it's a lot simpler. Each one can just define its payload and say, I'm going to write this data to this topic, and here's how you deserialize it and go figure it out. it gets a lot easier. They start to plug together in a more uniform way. So there is real cost, to be sure. More services does mean more work, but sometimes it means the right kind of work, and sometimes it's easier than you think. Now that we had this structure, we had to actually figure out how to make it reliable at scale. So Jose, tell us about DevOps.
DevOps. So at this point, we have Kafka, we got microservices. We're really happy about on the dev side of the project, right? It's fast, it's easy to work on, we can iterate, it's awesome. But the collector was a nightmare to work on. It actually burned out a lot of engineers. They maybe lasted a year on the team and then they're gone, right? So, and this was because the project was done by just all developers, right? And we really we wanted to avoid this happening on the new pipeline. So we decided to put some ops in the dev and make it all better. There we go. So DevOps. You're all probably been hearing about it a lot. This is a Google Trends chart on the popularity of DevOps in the last 5 years. Being a developer, I really didn't understand what it meant. I'm just coding away, and it just keeps happening. I hear it in Twitter, in conferences, people talking about it. So I went ahead and asked Alice, hey, Alice, what is DevOps? So I'm actually glad that she did our talk before this, because I said like a segue to it. So this is how Alice explains DevOps. DevOps means empathy and communication over the wall until there is no more wall. So now you're asking, so wait, what is this wall that Alice is talking about? So let me explain this wall through an example. So in a traditional engineering org, you have developers in the product team and ops people in the site reliability team, right? So let's say that me as a developer, I need some hardware. So I'm like, hey, Jonathan, I need 3 Cassandra servers ASAP. And I'm being very vague, right? Because I'm not used to working with operations people. And I'm like, I have a deadline I need to meet, and there's some pressure, so I need this fast. And Jonathan, he's traditionally he's in like an organization that's serving other teams and multiple products, and he's working through a ticketing system, right? So my ticket went in, and it's probably like third in line. So, but I have no visibility to this. So I'm waiting and getting frustrated because I'm thinking, hey, what's going on? The operations people are so slow. What's going on? And then eventually, Jonathan came back and said, hey, Jose, I'm so sorry it took so long. There was a big queue. But here, I got your 3 Cassandra servers. But keep in mind that my goal is to ship this product, that I need Cassandra for. But Jonathan's goals are work through the ticket stream, right? Help as many teams as you can. So since I was very vague, I didn't specify, hey, I actually needed Cassandra 3.0. And he gave me like whatever the default was. So now the whole cycle repeats itself.
This has actually happened.
Yeah, this actually happened. We used to work together in another team. So in the DevOps world, the idea is like, why don't we just go back to like scrappy, New Relic, year 1 roots, where you're like sitting together, working on the same team, New Relic v1. So that's the idea of DevOps. Yeah. So what this means is that rather than having SREs as like consultants that come or help you out, or sorry, not consultants, but like ticketing machines, they actually join your team, right? So once they're on your team, they have the same goals. It's ship, whatever product you're working on, right? So once they're on your team, there's faster communication, there's less back and forth where you're more productive because you're working with them on the same thing. And also, not only that, but they bring like a broader perspective because traditionally, like devs code it up, throw it over the wall, and then SRE is gonna like run the software. And in the example before, rather than like sending a ticket, we basically just kind of book a room, sit, work on it together, parent it. It might take a day, but that's like way better than weeks that it would have taken in the traditional model. So that's great. We're more productive. We can get ship stuff faster. But There's other benefits that I've seen that happen when you introduce DevOps to a team culture. Sorry, and so team culture is the thing that changes, right? So I'm an engineer, I'm a developer. My vision is very narrow. It's like, what's the next feature I gotta do? What's the deadline? I'm just gonna try and get it, use my own judgment of like, writing tests or not, or but then SREs, since they're more used to like running the software, they have a broader perspective, right? And it's really good to have them in your team and in those meetings where decisions are made, right? Because I've been in teams where it's all developers, and we've obviously made the wrong choices, because then the software that we're building becomes these monoliths that we're they're trying to crush now. So how did we do it? As Jonathan mentioned, there's this session going on in parallel right now that talks exactly how we did it. But the gist of it is this event that we had called Upscale. What Upscale was is that we grabbed all the product organization, developers, SREs, and we just asked them, pick a product, right? So there were like tables where you would just, it was the browser product, Insights product, and we just walk in to whatever you were interested in. But what it did is that now that team owned its entire stack, the UI, the services, the backend. And then we had we went from a team of maybe one SRE to a team of a 50-50 split. 3 developers, 3 SREs. And honestly, the results have been great. I was a little hesitant about it. It was like, hey, we're gonna lose our velocity. What's going on? But we ended up being a lot faster, because if you think about it, when we were hitting these roadblocks, they were because we were kind of waiting on hardware, or trying sending a ticket over to the SRE org and waiting for that. So I highly suggest you watch the talk. I think it's called Inversion of Control. Inversion of Control. So watch the recording. So to wrap this section, we'd like to introduce a new role that we think should replace the SRE role. Because traditionally, SREs are, it's a pool of them. They kind of get handed out to teams for maybe 3-4 months, or maybe once a feature is launched. But we don't think that works that well. So what we'd like to introduce is the idea of a product reliability engineer. So rather than having an SRE that just joins your team for temporarily, it's an SRE that's permanently on that team. So what this does is that they are they own the product as well. So they're interested in the product's goals, and they want the product to ship. So they're working with you together. Now, what we've noticed is that in teams that own their entire stack, so the UI to the backend, if they don't have an SRE, it's we can see that they struggle a bit. And some teams are lucky that they have a developer that's kind of interested in operations and databases, and they kind of take on that role, but they're kind of balancing their coding duties and ops duties. So what we suggest is, rather than having them balance it, just train up the person to become your SRE, right? Rather and just make it that. That's their responsibility. We honestly think sometimes teams that own their entire stack are too dev heavy. They should have at least one SRE. Jonathan?
All right, so now that we've devved some ops, we're going to talk about how containers made this even better. So Docker is everywhere at New Relic. It is the fastest way to get something done. We've got a big infrastructure to run it. When our team was getting started, we was obviously we're going to build it in Docker. That's going to be the fastest way to get going. The thing we were replacing certainly didn't run in Docker. It was a huge pain to deploy. If it had run in Docker, it probably wouldn't need replacing because of an interesting property of Docker that I don't think gets quite enough attention. And it's that Docker is opinionated about software architecture in a way that encourages more robustly crafted applications. Let's think about that for a second. What this really means is that it puts guardrails a little bit around what your app can do and shouldn't do. It makes the right thing much easier. In some cases, it forces you to do the right thing. The power of Docker is not so much in its technology, which is interesting in its own right, but the the seed, the germ of what makes this interesting to an organization, especially as it relates to bringing ops and dev together in alignment, has to do with how it surfaces operational concerns to application developers in a way that's understandable to them, and again, forces them to do the right thing. When you give too much leeway to how people develop software, you kind of end up with stuff that gets grown organically, and no matter how much documentation you add, the thing is never really going to be useful or fun or interesting to use. It's very different from craft, and it's very different from creativity within constraints. When you have designs that are more carefully thought through, you get a useful property that Docker has called affordance. The service presents its interface in a way that matches our capabilities to the need. You're capable of making an API request to something. Your need is to get the logs. Why not make the logs available over an API request? Docker makes that happen for you, and it gives it to you for free. Docker presents standard operational interfaces for almost all interesting service operations. Restarts, deployment, again, logging, signals, shells, all that stuff is just there no matter how the service is built. For our team, because we built everything in Docker, anybody that comes onto the team needs to only learn one way to package, one way to deploy, one way to interact with the logs. It's not a surprise. You don't have this monolith, well, oh, you have to learn how to read its logs, and this thing, the way it does database thread pools is different, and the way that it does deployments is different. We can't afford to have that anymore. The system is too complex. It needs to be simpler, have more framework around it, more rules, so that they can work together dynamically. We were so taken with this property that we decided, well, you know what doesn't run in Docker yet is Cassandra. When we started the process, we had Docker running all this stream processing stuff, but Cassandra was very traditionally managed because that's how we did all the databases at New Relic. What we found, though, was that no matter how fast and how hard we wanted to iterate on Cassandra, it still just took too long. It would take us hours to get a simple config change out to do performance testing. The reason for that was, well, it's a database, and we manage databases in configuration management. And as soon as you touch configuration management, you might be touching all the servers, and you better just go get coffee because this is going to take a while. Who has that kind of time? I'm now spoiled because all my other services are in Docker, and I can deploy those things in 10 minutes without asking permission. Why can't my database work the same way? Well, in our case, it was good because we were already working in the dark. We already had a system that customers weren't seeing. So if we break it horribly by running it in Docker, we're the only ones at risk here. So great opportunity. Oh, crap, it's a database. You know what Docker's not designed to run? Databases. Guess what it doesn't care about? What's on disk. So we had some work to do. We actually spent about 6 or 8 weeks, and we did some serious change to our deployment system, Centurion, which is actually, you can use yourself. It's a little bit like a Capistrano for Docker. And since it's just Ruby, we were able to teach it how to interact with Cassandra over JMX and push all the buttons. We wrote some config management stuff to make services that run Cassandra in Docker just that, so that we could have persistent disk presented to the Cassandra services. Lots of work, it's a big job, but we were able to go from taking hours and 3 teams to deploy a change to Cassandra to taking 30 minutes and 1 team whenever we want. The payoff was tremendous. We may have spent 6 to 8 weeks just making this work, but a year, 15 months on, we still get tremendous benefit out of this. Because again, that affordance is so powerful. We don't need to code up a bunch of different build scripts. We just make Docker images. It's not a surprise. It also forces us to make better software. Again, Cassandra's properties about how you have to be on the server to interact with it, about how much it cares about disks, aren't necessarily great. It's just sort of how it evolved. But cramming it in Docker actually helped us out because it makes it easier to work with. We have a system that anybody can run. So, we've got optimized builds of Cassandra in Docker. Now other teams can actually use that, and it's pretty powerful. So how in the world do you do this, right? So you've got cool story, bro, but my monolith isn't like your monolith. Well, for us, it was start small, and I hope this could work for you. Get that wedge in the door. Start with the new services. Build them in containers. Build them the new way. The stuff available to do this is getting better all the time. Centurion, like I said, can automate your deployments. Kubernetes, Mesos, and the like are all getting pretty mature. You can run this stuff in the Google Cloud Platform and in ECS on Amazon. this stuff is pretty solid now. It's been around for a while. It may seem scary and weird, and it is, but it can really help out with all the things that you do. So there's your shopping list. Treat data intake as a stream. Put it in a stream processor. Break up your monoliths one stream at a time. Put some ops in your dev. It'll taste delicious. And do it in containers because it makes things so much better. And I got to tell you, getting that monolith torn down really does so much to open up your work to the joy of creation. The things you learn tearing one of these down will help you learn how to never build one again. Thank you. Thank you for staying. We have about 10 minutes for Q&A, so if you all have any questions, please stand up, and our helpful MC, Ashley, will come to you with a microphone.
You mentioned midway through your talk that the collector was a big problem and it burnt out a lot of devs, but you kind of talked about replacing stuff kind of downstream from the collector. Did you ever get back around to actually replacing the collector or with something microservices?
So the way we're tackling it is, as I said, one stream at a time. So it's put it downstream. We're going to have to do that a dozen more times. That sound about right? Yeah. So there's a lot of things in there, as I showed. So the goal is eventually to just not have it, but to tear it out one piece at a time. And right now it's kind of a hot potato. Like whichever team has the most services still in there has to own it. So we're sort of racing like, okay, we've got these 3 things left we got to tear out. Like, let's get it going. But yeah, we're still in process with that. It's not done by any stretch.
The company that I work for, actually the state of California, is currently going through a journey on DevOps. Mm-hmm. And we're at the point where we're trying to scope out what the DevOps engineers are going to do. So from us, in our perspective, that's continuous integration and facilitating the developers. The site reliability engineer role, I've read about that and the way that Google uses it. It sounds like you guys are using it the same way at New Relic. Do you guys have the product reliability engineer, or I'm kind of thinking that's what we're thinking of as a DevOps engineer today?
A product reliability engineer? No, Jose and I just made that up.
Yeah, hashtag.
So we continue to have the title site reliability engineer. You can imagine it as analogous to another specialty like QA engineer. Prior to the upscale reorg, site reliability, that title, site reliability engineer, was the exclusive domain of a site engineering organization. And if you had that title, you were necessarily attached to that organization in some form or another. But we sort of blew that up and made like a caterpillar, liquefied and rearranged all the everybody's. And so now that's just like teams that own a product or a pile of services. And those teams have whatever engineers with whatever titles are most appropriate for working on that thing. So we don't treat those specialties as areas of responsibility. We treat them as areas of knowledge or expertise. Is that sort of where you're getting at? So I sort of rankle at the idea of like, oh, you're a DevOps engineer, therefore you only do these things. I feel like that's an artificial boundary, and the idea is that, oh, you're a reliability engineer, that means you're really good at understanding reliable systems, and I'm not going to expect you to like get really good at JVM tuning unless you're interested in it, or get really good at understanding enterprise software patterns or optimizing for loops. But if you know how to make a database sing, like, awesome, that's how you advance within that title. Jose, do you have anything you want to add to
No,
that?
I mean, the difference I wanted to make with I'm going to move over here for the feedback. With product reliability engineers, that in the past when we had worked with the Google way of doing the SREs, like I felt like as a developer that the SREs were on loan to us. And on top of that, they also were working with other teams. Right, so there was still kind of like a mini ticket queue rather than a bigger ticket queue. And then when we did upscale, and Jonathan and Alice and Leslie, another coworker, joined the team, like they were part of the team, right? So their goal was to seeing this product, this new pipeline launch, and they were not going to leave 6 months out or whatever. So that's kind of like the gist of like what a product reliability engineer is.
Yeah, we actually, Jose and I worked together when I was a site reliability engineer in the Google parlance. And so I was attached to 5 other teams in addition to his, working with all those groups on their reliability. And while it was great and a helpful form, that long-term vision for like, I'm going to make this thing and then I'm going to be supporting it 12 months from now, was sort of missing. And so there are teams that have work that I did for them a year ago under that model. I'm no longer attached to that team or involved in any way, but they have to support it, and that sort of creates an awkward transition period that with product reliability, you don't have that sort of issue. Expectations are different, yeah.
On the Dockerizing the database, the TLDR.
Short version of Dockerizing your databases? There is no short version.
I guess, I mean, the short version is that I can manage a database now as a developer because it's just Docker deploy. I need to look at the logs, Docker logs. In the past, I had to like SSH in the box and then ask John, hey, what's the command to get the log? Where are the logs at?
I couldn't hear the question, I'm sorry.
Are we just changing the app and not the data store? Is that the question?
Can you give me the mic, please? Thank you.
Are you just changing the Cassandra binary and not the data store? Or?
No, we're just, how do you
Well,
say?
so there exists Cassandra Docker images that the Cassandra Foundation publishes. That's great. That was a really helpful start. So technologically, what we did was we made this concept of like a Dockerized Cassandra host. So, an AMI, imagine. And so it runs a sort of specialized Docker that just does that. And so it will do things like volume mounts. So we'll expose the native disks into the container. Mm-hmm. We'll use host native networking. So we don't remap the ports. We let Cassandra map whatever ports it wants. We actually tune some of the disk subsystem things in ways that are friendly to Cassandra. So rather than using Docker for its multi-tenancy properties, we use it as a container deliverable, just a deployment artifact. Right. So that's the difference there. And thumbs up. Okay, cool. Yeah, that's what you were getting at.
So yeah, so we treat it as a service rather than a data store.
Yeah, we know how to deploy software, so let's deploy our databases like they're software. That's sort of the insight there. Another question in the back.
Kind of linked to that one, with Kafka, like when you went into that dark environment that wasn't customer facing, Kafka looked like an initial part of the infrastructure. So that came in Docker native. Did you have to solve persistent issues with that system? Did you learn something in that process?
Sounds like, where did Kafka come from? Like, what did we learn in that process? So Kafka pre-existed when we started this project. It's actually run by another team. We joke on our team that Kafka is like our electricity. If it goes out, like, nobody gets any work done. They don't run Kafka and Docker on that group?
No. So yeah, Kafka is the only thing I think that's not running in Docker, but we could.
Well, there are plenty of other non-Dockerized services still. It's not everybody's drank the Kool-Aid yet.
Right.
There's no reason you couldn't run Kafka and Docker similar to how we run Cassandra, but that is a very high-risk change for that team. They don't have a dark environment to operate Kafka in, so they just haven't made the jump yet.
I mean, we might think of doing that if they're like, hey, we're not going to have this big Kafka cluster that the entire company can use, but you guys have to make your own Kafka cluster, and then we might put it in Docker, just for fun.
So if you don't have the dark environment, then how do you microservice a monolith?
Well, you can still use the same pattern. Well, you really need that dark environment. You got to have something. I mean, you're shaking your head like, I can't possibly do that. You think hard about why. Like, how do you do QA without something that's not customer facing somewhere? We found Kafka to be super powerful for making these dark environments because it lets you duplicate traffic. Even read traffic, like we saw, was really, really powerful. Traffic duplication is a really important way to get sort of live QA environments, and Kafka is a pretty good way to do that. If you don't have anything like Kafka, there must be something you have, either continuous deployment, continuous integration. I hope so. It's 2016. I mean, there is no easy answer here. My answer is that it's essential. Like, this is something you have to have on the ground, because how else are you going to know that what you're extracting does the right stuff? It's a typical property of a monolith that the thing is untested. The thing is legacy code that no one really understands the complete specification for. You need to run some kind of environment that you can test it with that complete specification, which in our case we found was the actual traffic. Time for one last question. Gotten all your answers? Wonderful. Well, thank you again for joining us. Thank you for attending FutureStack. We'll see you at the keynote tonight. Have a safe trip home, everybody.
Yes, thank you both. The keynote is at 4:30 in about 15 minutes downstairs.